What do you want from a space telescope that set you back a cool $10 billion and led the entire world to hold its breath during the launch and deployment? The James Webb telescope is progressively acclimating to its new destination and is already returning images of the universe. The most recent images are breathtaking and stun the whole space industry. What is in the most recent image the James Webb Space Telescope delivered, and why is everyone gushing about it? Few space telescopes have garnered as much interest as the James Webb Space Telescope. Fewer telescopes have also been delayed as much as the JWST, and no telescope is as expensive. NASA, the European Space Agency, and the Canadian Space Agency collaborated to build the JWST. The JWST replaces the Hubble Space Telescope, which not only produced magnificent images, but was also critical in delivering scientific understanding about our universe and its beginnings. But because astronomers and scientists require better equipment to help us comprehend the cosmos, the JWST was built after decades of development and testing, and the government almost scrapped the project. On Christmas Day of last year, the JWST was launched. This wasn't your typical launch, since the telescope had to be folded to fit on the launch vehicle, and the primary mirror, which had a surface area 6 times greater and a diameter 2.7 times larger, had to be divided into 18 parts. Because the JWST was intended for a location that was too far away for astronauts to reach in order to repair it or even refuel it, there were no second chances for the development team. Nevertheless, everything went smoothly. The JWST arrived at its home about a month later. The signature heat shields, which also had to be folded, unfurled without incident. The launch was just so seamless that the JWST saved enough fuel to almost double its expected lifespan. The telescope will stop functioning when the fuel on board runs out, unless the engineers figure out a way to refuel it 1 million miles away. Since its arrival, NASA scientists and engineers have been hard at work configuring and calibrating the telescope. This is a complex process that took months because many parts of the telescope must be configured and collaborated, and they must be tested at each step, which includes taking images. The initial JWST image was an 18-star MOSAIC obtained in February. The image you see on the screen is a single blazing star in the constellation Ursa Major, known as HD 84406. Because the JWST's mirror segments were still being positioned, the star was observed in 18 different positions. This seemingly chaotic image was caused by JWST's mismatched mirror segments bouncing light back into the telescope's sensors. It was an important step in preparing Webb to take breathtaking images of the universe. The improvement was obvious when the JWST took another shot of the same star a few weeks later. NASA finished focusing the primary mirror of the James Webb Space Telescope on March the 11th with precision that exceeded all expectations. You can see the spectacular image of star 2 mass J17554042 plus 6551277, which NASA revealed on March 16, 2022. The image was noteworthy because it demonstrated that NASA's scientists were successful in accurately aligning each of the JWST's 18 primary mirror segments, giving the telescope its honeycomb mirror structure. The JWST has taken yet another milestone in its journey to begin exploring the cosmos. This was no small achievement because it required the alignment of 18 separate images into a single point of light focused within an accuracy of 50 nanometers, which is a fraction of the wavelength of infrared light that it will monitor in the future. By the end of April, NASA was confident that the JWST's alignment was complete, and the telescope was certified to be capable of taking sharp, well-focused images with each of its 4 powerful onboard science instruments. While there is a star in focus chosen for ease of identification, the image contains many galaxies in the background. The crew concluded the JWST could proceed with its next and final round of preparations, known as scientific instrument commissioning, after completing the 7th and final step of telescope alignment. Prior to the JWST being made available for scientific activities, this procedure took around 2 months. In the summer, NASA made more images available to the public that showed the telescope's entire field of vision. According to FEINBERG, who is in charge of the JWST's optical telescope component, the images showed what people from different backgrounds working together could achieve. While this was happening, the JWST kept the engineering team in awe with its optical performance. The telescope's mirrors are now directing fully focused light collected from space down into each instrument, and each one is successfully capturing images with the light being delivered to them. The image quality delivered to all instruments is diffraction limited, which simply means that the level of detail that can be seen is as fine as is physically possible given the size of the telescope, so NASA engineers don't have to make any substantial changes to the primary mirror segments. What you are currently viewing are engineering images of finely focused stars in each instrument's field of view, which show that the telescope is in perfect alignment and focus. The JWST was oriented at a portion of the Milky Way's small satellite galaxy, the Huge Magellanic Cloud, for this test. The view offers a dense field of hundreds of thousands of stars across all observatory sensors. You could note that the images' sizes differ and that they are positioned in an odd way. The images display how each of Webb's instruments is positioned with relation to one another within the telescope's focal plane, as they each aim towards a slightly off-centered region of the sky. The NIRCam, NIRSpec, and MIRI are the three imaging instruments on the telescope. Despite being a spectrograph, the fourth, NIRISS, can capture photographs for target acquisition and collaboration. The construction of NIRSpec's micro-shutter array, which contains several 100,000 programmable shutters that can be opened or shut to choose which light is delivered into the spectrograph, is what causes the dark areas you can see in some of the data. Additionally, there is the Fine Guidance Sensors, FGS, or NIRISS, which monitors guide stars to precisely and properly train the observatory. These two sensors are not typically intended for scientific imaging, but they can capture collaboration images that resemble those in this image. The image data is utilized to evaluate the sharpness of the images as well as to carefully measure and calibrate any slight image distortions and sensor alignment. After the alignment was complete, NASA focused on commissioning the science instruments on board, including detectors outfitted with specialized lenses, masks, filters, and equipment. The test will include pointing to different parts of the sky where the total quantity of solar radiation hitting the observatory will fluctuate in order to establish thermal stability when shifting targets. Meanwhile, NASA revealed another set of JWST images that are the most magnificent yet from the powerful telescope. The image depicts the Huge Magellanic Cloud, obtained by the JWST's mid-infrared sensor for the second time. This instrument specializes in mid-infrared imaging. The MIRI test image is displayed at 7.7 microns, revealing a previously unseen portion of the large Magellanic Cloud. The LMC is a small satellite galaxy to our own Milky Way, yet it has dense star fields, making it an ideal field for testing Webb's next-generation capabilities. The picture contrasts a zoomed-in area of the MIRI image with an earlier image of the same target region captured by NASA's Spitzer space telescope using an infrared array camera. Spitzer is no longer operational, but it was one of the first to provide high-resolution images of the cosmos in both near and mid-infrared wavelengths. It comes as no surprise that the JWST produces images that humble Spitzer. Each of the new telescope's 18 mirror segments is larger than the single one on Spitzer. It is clear that the JWST will use its primary mirror in conjunction with its enhanced detectors to provide scientists with a much sharper view of the infrared sky, potentially leading to breakthroughs in deep space astronomy. For example, the image produced by JWST shows the emission from polycyclic aromatic hydrocarbons, or carbon and hydrogen molecules that play an important role in the thermal balance and chemistry of interstellar gas. When the JWST is ready to undertake scientific observations like these using MIRI will aid astronomers in discovering new facts about star and protoplanetary system formation. Based on the amount of development made, the JWST may be poised to perform miracles in the next months. What will the Space Telescope officially aim for first? That one is being kept a secret by the scientists. Let us know what you think of the James Webb Space Telescope in the comments section below. Thank you for watching, and don't forget to subscribe for more videos.